All right, it's going to go live. Look.
Don't worry, we'll eventually be consistent.
Save the gold. Save the gold. It's been a while, actually, Johnny. It always feels like that.
Well, I've been away for like, I don't know, 3 or 4 weeks. I've been teaching. It happens to fall on Tuesdays for the last 3 weeks or so.
All right, how is it?
Well, I still love doing it, so that's good. But yeah, it was good. It was fun. Got to teach at least, so per session it was like 75 people showed up and hung in there, for like 3 hours straight every time. So
wow,
I couldn't see them, right? I couldn't engage them. So I mean, I have to give these people props, man. It's like, they're like, to hang in there for like 3 hours straight, talking about sometimes some dense stuff, some dense material, especially if you're new to Go and stuff like that. I do my best to try and keep them engaged and everything else, but yeah, it's the material is the material, sometimes it gets pretty dense, but yeah, they hang in there and they're active, they ask questions, which are my best classes, when they actively engage and they're, kind of asking questions and the answers you give. That's a very good class when that happens. I love that.
Yeah. I bet it's nice. I bet it's good though. I could probably sit and watch you for 3 hours easily, Johnny. I'd enjoy it. Are you not tempted to just play a video? But no, they're engaging on chat, are they?
Right. Yeah. So the thing is, obviously, so what I usually tell my students is this: there's nothing here that I'm going to teach you that you can't Google around for, right? Like, I don't have some sort of, into how to teach you Go, or some sort of into information I'm going to share with you. It's all I've done is, organize it for you and created some exercises you can sort of apply what I'm going to teach you. And then I'm going to try to make it as fun for you as possible, right? And then the key benefit of doing a live class is that you get to ask me questions. It's not just a video that you listen to and you watch and you can't, it's just one way, right? We get to have an interaction, so take advantage of the interaction, right? That's the great value of live classes.
I also think that there's a value in knowing what to teach at what point, because information on the internet is very dispersed, and it's like I always love the old plumber story, which is a plumber goes to the house to fix a problem on the pipes, and he just turns a bit of a screw and it fixes. And the lady's like, "What? I'm paying you $100 for this?" And the plumber goes like, "No, you're paying me $100 to know what to fix." And that's the same thing. It's like you need to know what to teach at what point. Otherwise, it's just a big mess. And I see a lot of value in that.
Yep, indeed.
Yeah, I wish plumbers were that inexpensive. I had one recently. Rinsed me. I was the one leaking money. Needs to fix me after that, but I can't afford it.
I clearly never hired a plumber, Matt.
Yes. Yeah, you shun modern technology like pipes, don't you, Tiago?
Yeah.
Okay, good. Well, I'll tell you what, I'm really excited about this episode, so maybe we could get going and I'll do a little intro.
Are we on the tubes?
I think we're on the tubes, yeah.
Nice.
Maybe someone could confirm whether we're on the tubes or not.
Yeah, Chris is saying
mic and everything working.
We've got different. Yeah, your mic's working, John. Welcome, by the way.
It's been a while.
Yeah. Let's just do some faces. Yeah, it says that we're really quiet, Johnny.
Yeah, for some reason. I can hear you well.
Yeah.
It says we're quiet on
Yeah,
YouTube.
me too.
Maybe we're just not talking loud enough.
Yeah, we need to step it up.
Yeah. Can't be.
My gain's all the way up.
I could put my gain up a bit more, but
I really
mine
don't
is
need
the
anything
same.
telling Matt to yell at me all day.
John, you're here. I haven't seen you in a bit.
It's been a long time. I was like running late for this, so I'm like, hopefully they haven't started too much that I can't jump in, but we'll see.
Nah, you'd eventually be consistent.
Gold.
I'm 2 for 2 on this one.
Keep going. We'll edit them. We'll just keep one in the edit. I promise.
Oh yes.
We should do our local audio recordings in case. Oh yeah, Tiago, you may be a little loud. Could you turn your mic down a little? Yeah,
I can indeed.
It's really good, but you are properly loud.
Is that better?
A bit too much. That halfway, somewhere in between.
So is it too low now? Or
yeah, a little bit.
Yeah.
What about now?
Better.
And now?
Too much.
Too much.
It's like being at the dentist.
Wow.
I mean, opticians.
You joke, but I was at the dentist on Monday doing your root
That's good.
canal.
Oh,
Yeah.
that
That's
doesn't sound fun.
No, it's not. TV was on, so it was entertaining. How's the sound now?
I think that's perfect now.
good to me. Yeah.
Yeah,
Good.
I think we're good. They fix it in the edit, but thank you, Chris Brando, for helping us figure it out. Okay, right. This is it. It's all going really well. I just say that when it's not. It's
Bars
fake,
and
it's like fake
kilobytes.
news.
Oh yeah, do record locally.
Yes, we
And,
do still, because we've had a couple of crashes. So
Yeah.
is everyone
done.
able to do that?
Yep, done.
Doing it.
Doing it. Me
Guess
too.
that means we need to clap.
We do need to clap, yeah. So after three, so I'll do 1, 2, 3, clap. Okay, ready? 1, 2, 3. Bro.
Mm.
It doesn't sound good, but it is good.
We've managed to get a hang of this whole clapping thing.
Yes. Well,
become
because we had to
consistent.
abandon the cool system.
You say this, our guests are just gonna be like, "What is going on? How could they not get that down?"
Yeah, no. But the thing is, we wanted to do
Oh.
originally zero bound clapping.
No, you want to do zero bound. I don't think anybody else is on board.
Like no one else.
In the real world, we don't count from zero, Matt.
Yeah, but we're not in the real world. We're in Go Time land, where indexes are zero bound.
There we go.
And do our claps get eventually consistent?
Ooh.
Eventually, they will be made consistent. That's
Consistent.
true.
Yep. Yeah. They must be made
mean,
consistent, right?
In an ideal world, they never even look at the recordings.
Yeah.
So
Yeah.
maybe.
We shall see. Okay, I'm going to play the music. In a
Introduce.
minute. Going live, it says. We are live, though. Okay, sorry. We're just having some technical difficulties. Somebody may have had a nap and they've woken up a bit too late. I said May.
Uh-huh.
Okay. It says going live, and then I've got a little spinner on it. And now it says live. Okay. I think we were already live, though, weren't we?
It's recording,
just
so I wouldn't be
sounds.
shocked if we were.
Yeah, I think we were already live. That's okay. Johnny, maybe, or John, you could hang out in the Go Time FM channel for our regulars, and then if there's
man.
any... Oh, John, apparently you may be a tiny bit quiet now.
Oh boy.
Oh, boy. All right. And then we've got some music coming. Get ready, everyone. It's about to happen.
Let's do it. It's go time.
Hello and welcome to Go Time. I'm Matt Ryer. Today we're talking about eventual consistency and managing data at scale. If you're not sure what that means, don't worry. We're going to start at the very beginning. Helping me do that, I'm joined by Tiago Mendes. Hello, Tiago.
Hello. It's very
Well-
nice to be here. Thank you.
It's very nice to have you. Don't worry, it's not just me and you, Tiago. John Calhoun's also here. Hello, John. Welcome back.
Hey, Matt. Well, thanks for having me. It's been a while. I feel like I'm a guest now.
Yeah. Well, please,
You
you
like
know,
missed 10 episodes, you're just officially a guest at that point.
you're always welcome. That's the thing. Host or guest, whatever you like. And also, Johnny Boursiquot's here. Hello, Johnny.
Hello. Yes, I am back after a short. Is it short? Anyways, after a few weeks of
Yeah,
being away.
been busy.
Yeah, busy teaching and all that stuff. You know, my
Yeah.
other favorite thing to do, other than being on
Yes.
this show.
I hear people tell me that they've done one of your courses and loved it. So I do hear that feedback.
I enjoy hearing that. I
Mhm.
enjoy when students reach out and says, "Hey, you know, your teaching, your course, your live workshop, whatever it was, you know, helped me and my career and this and that." Oh man, I
Oh,
love to
wow.
hear that. As a teacher, it was one of the
Yeah.
best things you can hear. Yeah, for sure.
Amazing. Yeah, absolutely. Okay, Tiago, you spoke recently at GopherCon UK, didn't you?
That's right. I did.
How was it? First of all, how did you decide to do that? What was the story around that?
So essentially, it came from a problem. The talk originated from a problem that I have at work. So I work for an insurance company called Kava, and we have this problem, and I'll dive deeper into the problem, so I'm not going to go into too much detail, but we have the problem of changing data across multiple microservices in one go, where data either has changed or has not changed. It can't be in a intermediate state. We actually don't deal with eventual consistency there. And I found that it was a very interesting topic, and it was a very challenging topic. And it got me to research exactly what are the practices that we have and the patterns that we have to implement these types of changes. And I figured that there are some talks or some repos with Go doing this, but I found that there weren't a lot of talks or a lot of resources specific in Go. And I thought, well, this might be a very good talk, because it's a real world problem. It's actually a very challenging problem. A lot of things can go wrong. A lot of things go wrong. So yeah, that's how I decided that it would be a nice talk. And after 2 years or something of no conferencing, yeah, I felt it was a good thing.
Yeah, and I tell you what, it's probably the talk with the most questions that I've ever seen, honestly. Like, after your talk, how many questions? There was like 25 minutes
I don't know.
of questions or something.
I don't know. It was pretty interesting, because usually when you don't have questions, you always get yourself wondering, was this talk that boring that no one really has a question? When you have a lot of questions, you think, was this talk that shallow that I didn't explain anything? I think in that case, it was actually a really good thing, because it just highlighted how this problem can appear in many different and be solved. Like, there are a lot of different small things throughout this whole pattern that need to be fine-tuned to each business and to each app. And most of the questions were essentially about, I don't want to roll back my data. What if I just want my data to essentially be all of it committed? It doesn't matter if it's today or tomorrow. Or what if I don't want distributed microservices or anything? There are so many ways of solving this problem and fine-tuning it. Those questions were, as tough as it was to be there for 25 minutes and seeing the hands raised, I think it's also a good thing, because when that video comes out on YouTube, and if I ever need to apply for a job again, I'll just share that video, and it's my systems design interview there.
No, absolutely. Okay, so eventual consistency. Let's talk a bit about this. What is this problem? It's kind of one of those ones where I think non-technical people are quite shocked by the fact that this happens. Who wants to have a stab at just high level? What do we mean? When does this happen? In what situation?
Well, I'm wondering if anyone else wants to have a stab at it. Now, I can definitely give a bit of an insight. So, eventual consistency is a problem that arises with the microservices and distributed world. So, with microservices, we usually also have databases all distributed. So whenever we want to make a transaction, so whenever we want to make a change, that has to affect multiple data sources. So imagine that you have policy table, profile table, and you have to change all of those, all of that data in one go. With a distributed system, that's very hard to achieve, because you need to make multiple requests and guarantee that the data changes. So eventual consistency, in my view, is you need to ask for the change to happen, and you just need to be okay with the fact that the change might not happen now. It might happen in 2 minutes, in 5 minutes, tomorrow, just because of networking problems. Services may be down. So eventual consistency means that you make a request now, the data eventually is guaranteed to all be changed, and you will eventually get all of that data changed. And it's I noticed that it's a hard topic to actually explain. It's hard to explain this eventual consistency thing. Find a good analogy for it, and I thought about the analogy of, so two people that want to meet somewhere. It's a 3-hour drive, and one person takes 2 hours, the other takes 3 hours, and they both leave at the appropriate time, but one person gets stuck in traffic. The other person arrives, but eventually that first person will also arrive there, and eventually they'll be consistent and meet each other. Not sure if it's the best analogy, but it was what I could think of.
So if I may sort of add a little bit of nuance to that, right? So So when we talk about consistency, right, the that's sort of at the storage layer, right? So if we let's take it one step, before that, right? So say to give an example, if you have say a system, whether is made up of multiple parts, right? So say you go on a shopping website, and you have one part of the system that is responsible for taking in the order, right? And then there's another part of the system that the first system communicates with to basically have to handle the credit card transaction, right? To basically charge the customers a credit card and to send back some sort of yay or nay, and allowing yet another system to handle maybe the shipping of that, right? So you have all these different systems that need to be aware of, right, that a transaction has occurred, that we need to package this stuff and send it over to the customer, right? So even before the storage comes in, right, what do you do, right, if for whatever reason the first system that takes the order, say the shopping cart component, right, it makes a request over to the credit card processing system. It succeeds, right, in charging the customer, but then when we try to go talk to the shipping, right, a component, it fails, right? So now here you are, you haven't actually stored anything yet, perhaps, right? But here you are in a 3 interaction, right, system where part of the transaction has succeeded, but part of it has failed. How do you handle the situation? This is not as simple as doing a rollback, right, of a database commit, right? Because you already have one system that's communicated to a third party to process a credit card transaction, which has succeeded. You can't exactly roll that back, right? So it's not an all or nothing kind of situation. So the part of building these kinds of distributed systems is basically figuring out, yes, there's a storage mechanism, which is going to be, you can rely on eventual consistency there. But what do you do, right, when you have a multi-step process where some of those steps could fail? Right, and you might have to reprocess the same thing, right? Or when something fails because the system is unavailable, or the third party you're talking to is unavailable. There's some upstream or downstream dependency issues. Like, this is why distributed systems are so hard, not just at the consistency of the storage layer, but really throughout the whole stack. This is why it's such a challenging kind of problem to space to be in. Not impossible, just challenging, but fun too.
Yeah.
Yeah, so Tiago, in your talk, you mentioned the Saga pattern, and maybe you could tell us a little bit about what that is for anybody not familiar, and what the alternatives are as well.
Sure. So the Saga pattern, and what is surprising is that the Saga pattern was described first on a paper in '87, so it's nothing new. But the time it was described, it was a pattern for long-lived transaction in a local database, so transactions that take a long time in getting those transactions done. And what happened is that with the advent of microservices, this Saga pattern was then adapted to handle the distributed system case. And the Saga pattern, it's not an acronym. A lot of people ask what's Saga, what's exactly an acronym. I think it's Saga pattern because each of the intervenients are called sagas, or each of the transactions are called sagas. So yeah, what it does is it comes in 2 flavors. One of them is it's a pattern that allows you to change data in microservices and guarantee that those changes will be consistent. And it has those rollback mechanisms that can still be hard to get, but it does feature a rollback mechanism. And the 2 ways you can do the Saga pattern is by choreography, where you have each individual service just emitting and consuming events to process the data changes. So there's an event saying, picking up Johnny's example, there's an event saying there was an order created, please process this order. Then the order is created. Then there's an event saying we need to process a payment. Then the payment service is responsible for processing that payment. Then there's the event saying payment process, please ship. And there's another service handling this event. So that's one way to do it. The other way to do it is by orchestration, where you have a central brain. And that central brain is responsible for creating messages to each individual service. And so the central brain says, okay, we need to make a new order. Order service, please create a new order. Order service says, okay, order created, etc. And we go for the shipping service, the payment service. And once all that is done, it's up to the orchestrator to just finish up successfully. And in a nutshell, that's what the Saga pattern is about. The alternatives are essentially, I think there are some different alternatives that I haven't really explored, but people often talk about a two-phase commit. And the two-phase commit is when you query each service and say, I want you to update this data. The service doesn't update the data yet. The service says, okay, I'm prepared to update this data. And you call all services. All services will give you the okay. So you call service A, okay, service B, okay, service C, okay. Okay, then we're good to go. And then you call the services again and say, okay, then do the commit. The problem with two-phase commit and why people tend to go for Sagas is that a lot of things can go wrong, because a service can say, I'm okay to commit, and then when you go to commit, it fails. And then you have a situation where you might have to manually intervene or then develop another mechanism to fix these changes and make things consistent. If the coordinator goes down, you end up in a state where the coordinator made a request to one service, it went down, and then what happens then? The service already changed, but the others didn't. So there are a lot of things that couldn't go wrong, and Saga tries to solve this by using the asynchronicity of all of these transactions.
Now, it sounds like, since that paper, or the original ideas came from 1987, I feel like this ought to have just been solved by now, isn't it? It's common enough a problem, but we all tackle it ourselves still. Why is that, do you think?
It's an interesting question. I think so. I was surprised by two things after the talk. I was surprised in one point about how many people already talk about this problem online. Like, there are a lot of very interesting talks, a lot of people already solving it. So it seems like it is a standard, because if you go to even Azure and AWS, they have in their docs how to implement the Saga pattern using their infrastructure. I think they even have the infrastructure set up to deal with Saga. So you already have platforms that come with this out of the box, and you don't need to implement anything yourself. I have a feeling, and I can't confirm this with any type of data, that it's just a pattern that is not yet very widespread. And a lot of people, when they see this problem at work or day-to-day lives, you try to think by yourself, because you think, well, this is a unique problem. We know all the information from Microservices books, but a lot of books don't cover exactly a Saga pattern. They just cover how you can deal with this. And so people end up dealing with it themselves without researching that there's a Saga pattern, which is perfectly valid. Like, if it solves your problem, it solves your problem. You don't need to go to a technical description of how you're solving it. So my gut feeling tells me that there are a lot of people that already use the Saga pattern without knowing that they're using the Saga pattern.
To add to that, I would probably guess that, like, for a majority of people, they probably don't need to use eventual consistency or anything that complex. Like, a lot of us work at large companies where we get it, we get introduced to that. So if you're to Google or something, you pretty much have to deal with it. But if you're working at a smaller company, introducing this is just a lot of complexity you don't need. So I'm guessing there's just a ton of developers out there who never actually have to implement it. So the result of there is that, like, they don't really learn about it or put it to practice. And anybody who's learned about algorithms or anything like that knows that until you've actually coded it, and knowing it in theory and knowing how to actually implement it is like two completely different things.
So true.
Yeah. So it's very interesting. This idea. I think some of the technical problems that we face are probably quite unique, and it'd be interesting because you could imagine there being like a Go package that you can just pick up and just use, and I know there are some examples of frameworks like that, but I find that in some way your problems really are quite unique. But obviously, like, learning a pattern like this from people that have implemented it can only really help there. But it's interesting. So one of the other questions I had about this was whether system design itself can help here. And so I'm thinking things like idempotency or idempotency, if you like. Do things like that help? If the fact, when we're talking about message queues and messages flying around, they may or may not make it. And you kind of have to assume that sometimes they're not going to make it. Like, which is kind of unusual when you're programming, because you tend to think of, you just write code and you don't assume at any point something's just not going to work, really.
Yeah.
Or that you're gonna get the same message multiple times. That is very, very common within distributed systems, right? So you kind of have to factor in idempotency.
Why does that
Yeah.
happen? Why does it happen that you get the same message multiple times?
Well, you can imagine if you have, say, you have a cluster of systems who are responsible for relaying a certain message at a certain time. Maybe the coordination, and this is, and I have a feeling it's going to vary from product to product. But assuming you have a system where you require some coordination to relay that a particular message was communicated, or that a client picked up a message, or whatever it is. It could be timing, it could be however they track which message has already been communicated, and because you might have some overlap at some point, though rare, it does happen, right? So it could be that the same message finds itself, sort of staying in a queue when it's already been picked up, or the window for it, for whatever reason doesn't get set, to hide it from other clients picking it up. So that message, ends up getting picked up again multiple times, sometimes by the same client, sometimes by other clients. So you kind of need to sort of factor in the fact that in a distributed system, especially when messages are involved, which is a common thing for evented systems, or where you need to do asynchronous communication, using queues and Event Bridge, for example, is a common one now with AWS and whatnot. So these kinds of systems, you kind of have to factor in the fact that you may get a message, right, multiple times, and it's up to you as a developer, right? They're not going to solve it at a systems level at this point. It's up to you as a developer, right, to engineer your software for that eventuality.
So, and this is this idempotency word. How do you all say that word, by the way?
Idempotency.
Thank you.
Idempotency.
Yeah. Okay.
Yeah.
Idempotency. Cool.
You want to try it
Cool.
again?
That doesn't mean it's correct. It's just the way I say it.
Yeah. I'll just go with peer pressure. I'm happy with that.
I think one thing that's interesting about the messages, like what Johnny was saying, is that in the ideal world, you want something that's like you get every message exactly once. But we all know that's not realistic. So like you kind of have two choices. It's like you occasionally don't get messages, which could be awful, or you have the opposite of you might get messages multiple times. And when you're looking at the two trade-offs, like getting them multiple times is clearly a better option than not knowing about something you needed to know about.
Yeah, right. So then idempotency then is the idea that if, assuming you get the same message twice, your system should be in the same state as if you just got it once. And a simple example is like addition, like a +1 message is not idempotent. If you get two of those +1 messages and you've got some value, it's going to end up being +2. If however you get a value that says set it to the number 1, if you get that message twice, then it's okay. You get it once, it sets it to number 1. The second message comes in, you set it to number 1, and you're in the same state. So, and that's like a contrived example, but when you build your own systems, you will understand. I think you'll see that for anyone that hasn't done it before, you'll see in your particular case a real example probably of that kind of thing. And so, yeah, sometimes it's like, well, I think you have to assume that you're going to get the messages multiple times. Francesc Campoy, actually, of Just for Funk fame, told me, and loads of other things, told me once of a time when he was building something and for whatever reason, like 1 in 100 messages just took a long time, or like a request was made. It just took a really long time. So the way they dealt with it was they would just always make 2 requests. And if, whichever one came back first would just cancel the other one. So almost by design they're sending multiple messages. So you kind of need then some resilience with idempotency or something in that case.
One of the top tips around that are usually mentioned is to use transaction IDs, so that you can use these transaction IDs to know if this particular transaction ID was already processed or not. Because, for example, if you're changing data, you don't need to exactly have a +1, but you might be getting into the case where you're updating your database twice or whatever, which wouldn't be a critical case, but still you probably don't want to do that operation. But for example, in banking, if the request really is transfer £10 to that other account, you don't want to process that message twice. So you can use transaction IDs to guarantee that if this message comes, you just don't process it again because you already processed this transaction ID, you just throw it away. And that's one of the key things also about Sagas, is to use transaction IDs that help you in more than just this, but it's very, very helpful to guarantee that you're not making the wrong changes.
Yeah, one example that I think people might be familiar with is when you do an update in like a SQL request, a SQL command executed. You can sometimes have conditions, can't you, on an update? So you can say, update this if the particular value is what you expect it to be. And I've seen this done with like a version number as well in the row. So, you might read the record and you see it's version 9, and then you say, okay, make this update on the condition that the version is still 9. And then if anyone's been in there before that to update it, that will fail because something else has changed. You have to sort of go back and then do it. So that's kind of one example of a simpler version, I think. But maybe you could tell us a bit more about the Saga pattern. Like, how does it actually work and what does it do?
So I'm going to focus a bit more on the orchestration pattern. I haven't had a lot of experience with choreography. So with orchestration, what happens is you have, again, a central brain that is coordinating the changes. And whenever there's a request that says, I need to change data in these free services, or for example, there's a new order here. Let's pick up that order example because it's a really good one and it's one that is often used in these cases. So there's a new order. So the orchestrator will then be responsible for putting a message in the queue and saying, new order, there's a command to update the order. And the order service will be responsible for getting that and taking that stock out of order or holding that stock, whatever it might be. And then it will reply. So there's a concept of a reply channel within your message broker. So you use a message broker for this. And there's a concept of a reply channel, which the orchestrator is set to always listen to. And so when the order service says in this reply channel, it sends a command saying order updated, the Saga will then call the other service subsequently through this message broker. One important thing that the Saga orchestrator is also responsible for is to hold a log of the transactions and the state. So essentially, the Saga orchestrator will need to know in which state it is to know which of the services it should call next. And then finally, you have the concept of compensating your transactions. So in case you did the orders, you told the order service to hold the stock, you told the payment service to capture the payment or to hold the funds for the customer, and then you told the shipping service to ship. If the shipping service said, I cannot ship this, we're having problems, then you probably will need back for whatever reason. And again, there's a case here that you could just say, okay, you don't roll back, but you just wait until you can ship this. But let's suppose that we want to roll back here. What you would do is then start issuing compensation commands. And so in that reply message, instead of the command being move forward to the next step or I updated this, the command will be I failed, compensate. And the Saga orchestrator is then responsible to say, okay, then payment service compensate this, or for example, release the funds or refund the customer. Order service compensate this, so put the stock back in the place it was. And this is how these systems can self-heal. And the Saga will always keep the log of what's going on, of which point for each transaction ID. It's very important to have those transaction IDs to know which of the transaction you're talking about at this point. And you'll always keep a log of your steps and the compensating transactions that you need to do or the next transactions that you need to do.
So is this a case where every service, every microservice needs to know how to kind of undo itself, or maybe not, depending on your case?
It depends on the business, but if you need to roll back, if you want to have the concept in your business of rolling back data or the concept of rolling forward, for example, instead of deleting the row on the database, you add a new row with the previous data. That's also a valid way to do it. Each service should know how to compensate the transactions. Yeah.
Yeah. And it's interesting. This kind of speaks to why there isn't just a Go package that you can just implement, really, because a lot of it is about the business logic. A lot of it is very specific to what you want to happen in each case. But it kind of reminds me of errors in Go. I think we do kind of consider the failure case. So if we try and open a file, we know that may not open for whatever reason. So with Go, errors are brought to the forefront, aren't they? They're returned usually as the second or last argument, hopefully the second. And so we get these values back that we then immediately check, and we get into that habit. And I know that some people still kind of complain about this in Go, but it forces you to consider the failure case. It forces you to think upfront about what's going to happen if this thing goes wrong. So it kind of reminds me a bit of that.
And at this point, I think if someone still has a problem with the way Go handles errors, well, I have choice words for you, but this is a family-friendly show. Anyways, no, the thing is, I mean, it's there's a lot of truth to that, right? So I used to be one of those people complaining about the way Go handles errors. When I first came across it, and I'm like I'm not used to this. I'm used to sort of throwing things, catching things, and whatnot. I'm like where are the keywords? Where are the built-ins for that, right? And then I realized the first time I was forced to implement and design a system that was resilient enough. It just happens to be, I was communicating with some remote HTTP service, and I was getting throttled, and I didn't realize that until it went to production, whatever it is. I'm like, oh, okay, I need to do something about this. And there's easy ways of getting that, right? So basically using the error system to capture the fact that I'm getting throttled, checking those errors and implementing some sort of back off and implementing some sort of retry, things like that. Excuse me.
All right.
That was a retry.
Just guaranteed that cough is going to make it into the show.
I know, guarantee. Yeah. Let me retry this. Right. So basically, you using the language and using the what it provides you, right? There's a reason these things are there. So and to kind of tie this back to what we're talking about before around the sort of the design of these systems. Yes, it is hard to sort of have a framework or a package that you can just throw at things to sort of fix these kind of problems or implement them for you, because it's going to be very contextual to the business that you're in, to the problem domain that you're in. But for me, that is part of the fun, right? That is part of the engineering fun, right? I think everybody, if hopefully if you're lucky enough and you get to work on a system that is distributed, that is large enough to require these kinds of problems, I think some of these systems have been the most fun I've had, sort of engineering solutions, because they acknowledge the fact that the world is not sort of a linear sequence of events. There's always things going on, sort of concurrently or in parallel with whatever it is you're doing right now. So it's an acknowledgement of the reality of the world, that systems failed, network fails, disks fail. There's gonna be some sort of failure. It could even be sort of a business logic, right, that actually fails, or whatever it is you're trying to do. So it's an acknowledgement of the fact that things will not go as planned, and you should build in the resiliency, right, in your system, right, to be able to sort of accommodate for these kinds of these eventualities, right? So I think it's a perfectly reasonable thing to expect engineers working on systems of a certain size to know about the Saga pattern, for example, to know about how to build these resilient systems, and to work with their teams to figure out, okay, what are the different failure modes? What are the things that could go wrong in the process, right? What are the workflows that we need to set? What parts of the component can wait for other parts to recover, and things like that. So identifying these things, that is the beauty of engineering these kinds of solutions.
Yeah, that's very cool. You get me excited now. But I want to go and build some enormous thing.
You want to build some
but
distributed system.
On the topic of packages, I think there are a couple of packages implementing Sagas, and I think you can make this generic enough that, okay, you define your business logic, you define the functions that proceed with a transaction or compensate, and then you have the library that just wraps everything. But I think I couldn't agree more with Johnny. What's the fun in that? What's the fun in using something already built when you're dealing with this interesting problem? So yeah, I think it's always cool to build new things.
Yeah, it's funny as well, like what it leads you to do with eventual consistency. I have an example in the front end where the actual request would usually take some time, and in a big distributed system, if it was like, say, a chat app, one person might be in South America, another person might be in Scotland. So and it's possible that they won't be speaking to the same server in a distributed system. They're probably going to be talking to their own local servers, so it's faster. So what happens is then somebody in Scotland will make some comment, and if you build it so that you're kind of being very true about what's happening, that would take quite a while to complete. Like you would have to wait for it to be written to the local database, also then be copied across so that the person in South America can see it. And that might take some time. And so, things I've done this too in the past, where you kind of do some tricks to paper over this a little bit. For example, when you press enter on the message, you immediately pop it into the box so it looks like it's sent, even though that's just an illusion, while the request is still happening in the background and the consistency is still not there yet. You still have to wait, but you sort of assume or you pretend it's going to be fine, and only later, in our particular case, later, if there was a problem, you would then flag the message as, oh, there was some problem with this, you can retry or whatever, or it would even retry for you. And so you end up doing those kinds of little tricks to paper over the realities here. And if you think about like the internet, there's so many errors all the time happening on the internet, and we don't really notice them. We can still carry on like we're still just doing a live chat now. We're spread all over the world, us four. So that's always quite fun as well, I think, when you think about user experience and how that plays. Understanding that this is going to take time. It might fail, but we're going to assume it's not going to fail, and crack on with it.
Yeah.
I think there are. Go ahead.
Go ahead, Johnny. Oh, yeah, I think so.
This is a very polite show.
It is. We could spend the rest of the show just saying, "Go ahead, go ahead."
Go ahead. We've got ourselves a good old-fashioned polite off.
So there's a very one of my favorite talks around sagas. I haven't admittedly watched that many, but I really liked it. This talk is by a woman called Katie McCaffrey, and she was she had a lot of lead roles in Twitter and Microsoft, and she gives the example of sagas with the Halo game and dealing with the scoring, where each score comes from each individual Xbox, and then you have to commit all these scores to every other Xbox of all the other players. So imagine you're playing online, and imagine that you see your score is 100, and all other players will need to see that your score is 100 and their score is whatever it is. And so they also, but you can't really show people that their score is now lower than it was before. So you can't really roll back that score. And so what they did is, like, people don't care about having the score right away. So we just let the system heal itself. We just let the system eventually get all the scores to every person, because it doesn't really matter, because people will just go on to the next game and the score will eventually be there. And I think it's a really, really interesting example. The talk is brilliant. I recommend everyone to watch it if they're interested in this topic.
Yeah, well, please send us the link and we'll pop it into the show notes.
We
won't be able to put Tiago's talk in the show notes because I don't think it's going to be published by the time this episode goes out. But keep on GoTime FM on Twitter. We'll tweet it there, or eventually you'll find it. I got another example of a real one that I had, where I built this like game. It's like a choose your own adventure game on Twitter, where the audience chooses the branch to go down of the story by using Twitter polls. So the whole, all the followers vote, and that's the decision that's then taken. And when using the Twitter API to read the poll results, sometimes I'd get old data. And this again is down to eventual consistency. The fact that there may be some of the servers probably had the latest information, but it just hadn't propagated across the system yet. So for whatever reason, through the magic of routing around the internet, I was hitting a server with old data. And it reminds me of that Xbox score problem. So the fix was to just basically say, well, if there's no way to unvote on Twitter. So if there's fewer votes, ignore it. It's old data. And so that was like a bit of resilience that I didn't expect. And again, it's because I think I just assumed when you ask Twitter what's the latest results, they'll tell you what the latest results are. But of course, in the real world, it's not so easy. But that's another kind of interesting thing you have to do. And when
So
dealing with
there,
eventual consistency?
there are some systems that understand this dilemma and actually offer you a choice, right? For whether you want, when you make your request, whether you're okay with possibly stale data, or whether you want your request to be basically strongly consistent with what's basically in the cluster, right?
That's it's
So
really funny. That
you
is
you can ask for that, and basically
choice.
that comes, the trade-off, right, is comes at the cost of that your request might take longer. You might have to
Right.
pay a little more, right?
Mm.
But if that is, these are you willing to basically make that trade-off, you can make a request and it says, hey, I want all the servers in a cluster to synchronize and agree on what the latest is, right? Don't just give me the first one that is able to give me an answer that could possibly be stale. I want them to all figure out, okay, yep, we all agree that this is the right answer, and send that back to you. You incur that cost, right? That your request is going to be slower, and you're going to pay more for it. But if your problem domain is one that sort of requires that sort of consistency, there are systems out there that will provide that to you.
Yeah, so that's really interesting. Imagine seeing that in an API, though. It's like, would you like the rubbish version? It's fair enough. It
The
is a
cheap
trade-off.
version versus the expensive version, Matt, not the rubbish version.
I know, but that just seems like they're trying to upsell. It's like,
This is your API. You're like, you want the rubbish version or not? That's your flag.
It's like for the free one, it's fine, but occasionally it's just random crap data.
I mean, the examples I've always seen are like there's databases that do this where like if you have 5 database nodes and like you write and it's guaranteed to be written to say 3 of them so that like there's a quorum, I think so they call it.
Right.
Like there's a lot of databases that do that, and when you're reading there's certain data that you pretty much need to show up to date for certain reasons. Like if a user just created an order and it doesn't show up on their account, they're going to be like, well, what happened?
Yeah.
But on the other hand, if they're looking at like reviews for some products on your page, well, if those aren't up to date, it's not the end of the world. So it's kind of this deciding which data it's okay to do that with, because the downside is if you try to make everything up to date all the time, then you'd basically lose all the benefits of having this spread out database system that you have, because you'd be the same as just having like one sort of master you write to. And I know like master is probably the wrong word because I'm just used to the what SQL sort of terminology. But essentially, you have like one main one.
That's the main is the word you're looking for. Yeah.
So you have the main, and then you have the secondaries. Is that the new?
Primary, secondary, whatever set you want to use. Yeah.
Okay.
John, you're like an uncle that's really digging himself.
I am digging myself a hole. It's one of those things where like I've heard the terminology forever, and I know I need to change it, but I don't say them often enough because I'm not like around other engineers often enough to use them.
Yeah.
So it's like, darn it, I did that stupid thing again.
At least you're aware of it and are working on it. That's all we ask, right?
I try to keep up with it, but
with the kids,
it's hard sometimes.
No, but yeah, you're right. So that's the thing, that the advantage of having a fast system that is distributed is you don't have to wait so much for all that. But of course, sometimes you'd prefer it. And yeah, that's interesting. And I think it gives people a lot to think about when they're designing their system. And honestly, I think the user experience, which you mentioned, John, is kind of like something that you should consider to take into consideration, because like you say, users will expect something, and we have to kind of make sure that they get what they need, and that might well influence the design, and should influence the design of the system and these kinds of decisions.
If you think of, I was just going to mention, if you think of the case of insurance, where changing a data is not only something that you need to show the customer, but it's something that is reflected on a legal document, the final policy. It's like in which you have that final policy, that's the law. With whatever information is there, whatever the user declared there, it needs to be the most accurate information. If you have an inconsistency between this policy document and your systems, and then while your policy has one type of information, there's some other request that is very important, gets a different type of data, and then it shows a different type of data. This can actually be quite serious. So it goes a bit beyond just the user experience. It can have actually legal implications. So it's also interesting from that point of view.
So can you imagine a time where people had to, in the case of insurance, for example, where people had to sort of manually do data entry to process these things? So maybe you talk to your agent who then, you know, gets piece of paper or whatever it is. You know, back in the day, you used to go to an office and they would come to your house, whatever it is. And then by the time they leave your presence to go like commit to this transaction, right? I mean, your house could catch on fire. You could get into an accident, whatever it is. So that buffer where you have no, technically, legally, you have no coverage, right, in your insurance.
I guess that you can use the proof of communicating that, like, date and time. I communicated this at this date and time, so this is my accurate data. It kind of solves it for you, I reckon.
I was gonna say, I think they can sort of backdate some things too, to sort of, like, as long as they claim they received payment or something that was backdated, you're okay. Because I think I had some weird situation like that where something, like, I communicated it needed to be canceled and they tried to renew it, and I was like, no, I can sort of, like, just weird things like that. But I think even what is it, the health insurance you get if you leave a company? Is it Cobra?
Cobra, yeah.
I think Cobra, you can, like, sort of go back, and there's some things you can do weird with it where you can, like, almost turn it on retroactively or something, but I don't remember exactly how that works.
You only need to do that if you've hurt yourself, I suppose.
Yeah, it's weird the way it is, because I think you can opt for it or you can, like, retroactively, but you have, like, a short window to do it.
Like a 3-month period or something,
Yeah, and I don't know if it's because of that, like, in case they don't get the papers or something, you aren't left hanging. I don't really know.
Coming up next on Insurance Time, we're going to be talking about premiums. Well, we, of course, Tiago and I live in a country that has.
And there goes all the listeners and viewers.
You also work at Cover, don't you?
I do. That's why I keep talking about insurance, because it's the domain I'm familiar with in this circumstance. But on the topic of how complex it is to manage these systems, one of the funniest, most interesting question that I think summarizes everything around this that I had at GopherCon was, someone asked me, "Is this even worth it? Is it even worth us doing all this? Why don't we just have our old monolith?" And again, like, the answer is maybe an old monolith is the best solution for you. Like, no one says you really have to go into microservices, and sometimes it's just simpler to deal with a monolith, or even if you wanted to, if that little piece of your system is like, if the orders and the payment and the shipping are so interrelated, maybe just create a kind of a microlith just to manage that if you find that it's simpler. So there's no one size fits all. There's no one magic solution. And yeah, I think it's very interesting.
And then we should also mention a little bit about testing, because you know, that must be quite important, especially when we're talking about failure cases. Do you try and write tests or have some kind of test coverage for those failure cases? How do you make sure that the rollback stuff's working as expected?
So someone actually asked this during my talk, during the questions, and I think this to properly test this, you need to go to the integration testing level. I think unit tests can miss a lot of things here. If you go to the integration testing level, I think there's a concept. If you look at Stripe's API, they have a really interesting concept to test cards failing and cards with no funds. So they have different cards number for test cards that you can use. And one card number will be a card that requires 3DS and is okay to go. Another card number will always have an insufficient funds, and you can test it this way.
That's
so if
mine.
you think of Saga's this. Give me your number, Matt. I need to test that. And with Sagas, it's the same thing. You can think of an integration test where you send data with particular fields, like this transaction ID, or this particular transaction ID is a transaction ID that will fail at this step. And then you can test that your Saga on an integration level with all your message queues up, all your databases up, and you can test that your Saga does what it's supposed to. Yeah, and I think that's one of the ways to tackle this.
You could even test that in production. Yes, I mean, seriously, I'm being serious. Like you can literally, right, as part of a canary or something like that, right? Make sure that whenever you roll this out, that all of those failure cases that you think work and your CI and CD pipeline and your staging environment, whatever it is, that they actually do work in production as well once you roll it out, right?
Yeah.
Like I'm becoming more of a fan of testing in production in general. So that's what I'm saying. Yeah.
Do you need each service to implement rubbish mode again so that each service can actually fail?
No, right? Because if the service is doing what it's supposed to do, right? If you have a transaction that's supposed to fail, it will fail. If you try to talk to the credit, card charging service, and it sees that transaction, and that basically return a failure from something you expect to be a failure, then all the other systems don't need to know that, okay, we're all in testing mode, okay, all other components, that's what we're doing. No, they individually, they work as they're supposed to, and only you as the orchestrator know that, okay, this should fail at this particular step in the workflow, but you can do that in production.
It reminds me of that sentence from The Falcon and the Winter Soldier of "He's out of line, but he's right" about testing in production. It's actually not a bad idea when you think of it. Yeah.
Speaking of being out of line but right, it's time for Unpopular Opinions.
Unpopular opinions.
I actually think you should probably leave.
Okay, Tiago, have you brought an unpopular opinion with you today?
I have two, and you'll need to choose which is more unpopular, and that's the one you're going to use.
Well, we sort of make the rules on this show, actually. But yeah, we will do that, but it's because we want to, not because you've said it. Okay, yeah, go on then. What's your first one?
First one, and note that this comes from a first, but bass guitar is actually way cooler than electric guitar or just normal guitar.
Agreed.
Yeah.
Do you know what? I love the bass guitar.
Me too.
I can't vote on this because I tried to learn bass guitar and it was just too boring for me. It just didn't jive with me.
That's
like
why it's unpopular.
So, but the thing is, I couldn't do regular guitar either. Like neither one caught my interest. So I'm like,
you need
they
a
both
guitar
were just
with
boring.
5 strings. Sounds like you'd
they
be
were
good
just-
on that. You need the
I'm like, I don't know.
Goldilocks
They're
guitar.
both boring things, and I can't vote on which is more boring to me.
Boring. Amazing.
The other thing, which is the other unpopular opinion, which is a bit more on the techie side, is that move slower, think through things is more effective than move fast, break things. So that's a popular Facebook motto of move fast, break things. And I like to say, I think moving slower and thinking through things is actually more effective than moving fast and breaking things.
Well, definitely in Facebook's case. And those things, it's fine if those things are just like servers or bits of UI. But when they're democracies, then yeah, I would like to go a bit slower. Thank you. Okay, but do you not see, is there value in like the learning you get from actually implementing stuff? Like actually doing it always, for me, reveals things that I probably would never have thought of. Or maybe I would.
My caution comes from the place that you always need to be aware of the technical depth that you're introducing by move fast and think and break things. And if you can't pay that technical debt, it's fine. But if you can't, not making a good design decision, not thinking through a problem can really bite you in the long run.
I suspect this motto stems from the fact that it's the type of motto you'd hear from a small startup, where basically their option is moves fast and get like money before we go broke, because they don't have the time to move slow. And so while there might be cases where some are much better off moving slower, I think sometimes when you're just desperate to get any sort of income and to be able to stay alive, that leads to this like move fast, break things.
So there's this interesting book. I can't remember for the life of me. I can't remember the name of the book. And they explain an interesting phenomenon, which is the company that moved really fast to get on the market and made a lot of trade-offs. It can move fast, but then it has a line that starts being, it starts flatlining in terms of progress. Whereas the company that took a bit longer to go to the market, but have well-thought systems and architectured in a way that they can extend it, they can add new functionalities like that, they can actually pick up and even surpass it in the long run. And that's one thing that really stuck to me, because it can be quite cumbersome to have to maintain a lot of old code that wasn't really well thought of.
I mean, I absolutely agree that introducing too much debt could be a big issue. And I think the larger, more stable your company is, the more that applies. I would probably only disagree with that opinion in the case that there are definitely some companies that if you're trying to build something and you literally don't even know if you're going to be something people want to pay for or use, then spending months trying to design the perfect system might not be the best idea, given that, you might design a perfect system that nobody wants to use.
I agree with you there. That's why it's an unpopular opinion.
Even you don't agree with it. Yeah, well, and the other thing is like, to be honest, it probably depends. We need a jingle for "it depends," don't we? Really? But yes, but I see the kind of the merits in that, and actually, I think sometimes taking your time to think about something, you are gonna kind of you are, I don't know what I'm saying. Hopefully, this bit gets edited out. What I was gonna say though is. Oh, I've forgotten. I told you I had a nap, didn't I? The editors are really good. I love the editors on this show.
Wait, isn't a nap supposed to help your brain with these kinds of things?
Does it? It doesn't do
Yours
that for me.
does the reverse.
Yeah.
Does Matt not remember that they never edit anything out that he says?
Oh yeah. Oh no. What was I gonna say? Oh yeah. Making things easy to change and throw away, like moving fast. If you're not going to keep the thing, I think that's quite nice. So building something deliberately not very high fidelity, so that if you're testing those ideas, and then you throw it away, and you do have to throw it away. And I do find that I use that mechanism to learn, and then that will be how I design the system. And only after I've done a bit of that am I then ready to start to actually lay down some more serious foundations. And so in a sense, like I use that fast prototyping as part of the design process. So you could say I am doing quite a big design process there. I object only to when we just spend too much time in documents, and we're trying to imagine things, and you just, there will be things that happen that surprise you. So get it out there soon. But yeah, it's a very interesting point.
I think you should build your systems to be extendable. Like, don't try to picture and envision all of the perfect future that this system will do, but make it so that if a lot of things need to change, your system is resilient enough to be changed, and it can be very easily changeable. It's very flexible in that way.
Only after the third try.
But I do agree there's a lot of value in experimenting and throwing things away, and using technical debt to your advantage is also very valuable. So yeah, that's why it's an unpopular opinion.
Oh, I have one.
Oh, Johnny, what is it?
Matt, John, you want to go first? You have one?
It's all you, Johnny.
It's all me? Okay.
John's already done his. Did it
Oh,
earlier.
yeah, that's true. Yeah, John hates guitars. Damn.
Bass guitar's boring. That was it. That's amazing. I love that.
That's amazing.
Yeah.
But so here it is.
Yeah.
Blockchain.
Ooh, what?
Blockchain developer is the new hotness of jobs. Now, whether or not you care for or think blockchain is a scam or whatever it is that I see written out there, wherever you fall on the divide, right? Wherever there's money or potential for money, capitalists show up. People with money who want to make more money show up, and they're gonna throw lots of money at this thing, right? And the more I learn about this world, and I don't know a ton about it, but the more I learn about it, that from a business standpoint, not less so from a technical standpoint, but the more I see, I'm like, I start seeing job postings all over the place now for blockchain developer, and it's really is gonna be one of those kind of odd, kind of like a weird looking things, like you're gonna start seeing sort of pop up everywhere, and as with most things, as with most technology, right, there are two times, right, when the going is good, right, in those fields, right, before the market gets flooded, right, when everybody's competing on salary, right. So it's usually at the very beginning, right, of the technology, right, and at the very end, where there's only two people left who know the tech, right. Those are the two times when you really can make bank on a tech. And I think right now we're sort of in the infancy, right, at the beginning stages of this whole blockchain engineering and developer talent kind of wave. And again, regardless of how you feel about the technology or its applications, right, there's going to be a fervent need for people who understand that stuff, and they're going to be paid well, at least for the next 4 or 5 years or so. So if that's something that's of interest to you, hey, maybe now's time to take a look into it.
I feel that there's a new blockchain company starting up every day. At this point.
Pretty
I
much.
need to learn blockchain now and then learn like Haskell later, and I'll be golden. There's gotta be some service left, right?
If you know COBOL right now, you can charge a premium, my friend.
I've heard that with some of them, but it's just I don't know if I'd appreciate it.
Yeah, if you don't like bass guitar, you're not going to like COBOL.
You're not going to like COBOL. Yeah.
Boring. COBOL's one of those languages where the column matters. Like the first 6 columns or something, they mean something. They change. I don't really know. I don't know it, but
yeah, kind of like spaces mattering in Python.
Yeah, but weirder because it's like there's like lots of space, and each one means something, and you can change things like by putting something else in that space.
So I heard an unpopular opinion. Matt says Python is weird. That's what I heard.
That's very popular.
Yeah. Yeah. Well, this is a Go podcast, but I'm one of those people that's like, do what makes you happy and use whatever tool you like, and use Go, learn Go really, and just do that.
Yeah.
Yeah. Do learn Go though.
Yes.
Yeah.
Agreed.
You can do blockchain with Go, can't you?
After this, I will learn Go.
Yeah, you should, mate.
Yeah.
I think
you
it's
can do
time.
blockchain development. Yeah, you can do blockchain. Blockchain. Yeah, Go's hot in the blockchain, man.
Yeah.
Go is hot in that sector.
Yeah.
I feel like Johnny's like telling people that he's open for offers. Like very subtly, but he's like, just in case.
Subliminal messaging.
If you get a bunch of recruiters after this, it's your own fault.
Yeah.
And we know they're not going to make any sense. However long the blockchain's been around, they're going to say you need that plus 5 years of experience.
Yeah, exactly.
Well, if you've got any more questions, Johnny can be found on Twitter. J Boursiquot. Good luck spelling his name, though. That's clever.
Yeah, which is why you omitted that whole thing by posting my name up as Golang Johnny on Go Time FM.
Yeah, you can just. I can't believe that. You can just search Golang Johnny.
Yeah,
and you find Johnny. How cool is that?
I just assumed he officially changed his name.
Oh yeah,
for you.
That is my new career goal.
Yeah,
Golang Tiago or Tiago Lang, and you can find me.
Well, you could do it with a brand name.
Yeah,
but hang on, let's just do it. I'm just going to do it. Golang Tiago. You might be surprised.
You might be surprised. Yeah.
Golang Tiago. Nowhere to be seen. No, you are actually. You are on the front page of the search engine I'm using. Yeah, you are. You are there.
Is that Alta Vista?
No, I just asked Jeeves.
Oh, there's a package.dev. That's
there's
not
a package
me.
called there's a package called Tiago, that's unfortunate. Just gonna have a quick look at see what that package is. It's just a main file that just says it prints out. Tiago says, "Look, my very first contribution to a proper free software project," and that's it. How adorable is that? That's scratch Tiago main.go. Oh. I love the internet, and we'll post show notes to that repo so we can get the stars way up. Let's get this trending. Let's get this Tiago package trending.
To be clear, that is not mine.
No, yeah, it's too neat to be your code, Tiago.
Ooh, goodness gracious!
That means you've seen that means you've seen my code.
Yeah.
So you're already talking about it and generating buzz. That's my goal.
There you go. Then that's like fake code. It's like the fake news approach to code. I always know I've gone too far when Johnny goes, "Ooh." That's when I worry. Then, like, oh no, that's too much now. Johnny's like my canary. When he gets worried, about something, I do. Well, you believe it or not, that's our time. I can't believe it. It's been so interesting, and it's such an interesting subject that I'm sure we could continue to talk about for ages.
I feel there's going to be a part 2.
Yeah. Okay. Again, mate, wait till you're invited.
Eventually, you invite me.
Yeah, eventually it's going to happen. No, but definitely, Yes, thank you. Please do come back, Tiago. And, if you want to follow any of our panelists or guests on Twitter, you can do so. Check out the show notes. We link to their Twitter accounts there. I only say that because that's the kind of place we usually hang out. Not always, but there we go. Thank you so much, Tiago Mendes, for joining
for
us
having
today.
me.
No, it was our pleasure. Johnny Boursiquot was also here, as was John Calhoun. I don't need to say my name again because it's just weird, but bye. There we go. And that was our show. We're still live. We're still recording. And sometimes, by the way, after the show, little nuggets make it into the main bit. So it's just.
Oh yeah, did they do that?
Yeah. Sometimes it's gold, and then they get spliced in.
Spliced in.
Yeah, splice.
Yeah,
It's always
Tiago,
interesting.
Drop some nuggets.
Well, it's always interesting how these different topics like overlap so much. Because like we did an episode on event-driven design or event-driven systems, and like the two end up just being so like linked because they're used for similar problems and to solve this. How do you put stuff at scale?
Yeah.
Which still to this day is not an easy problem to solve.
I think if I've talked about choreography, you would see even a bigger overlap because choreography is purely event driven. It's a good thing I didn't.
Yeah, I mean, honestly, it would have been fine either way, but it's just funny listening to the two because you hear a lot of similarities, and even when they're technically two different ways of doing it, there's just so many similarities between the two.
I've also noticed looking at the stats that these sorts of system design episodes get a lot of attention. Like they're much more interesting to people for whatever reason. And by the way, the numbers for Go Time are really impressive. We have a lot of downloads and stuff, so we should be very happy with that. I don't know if we share it publicly, so I won't. But
I have no idea what they share, but
yeah,
I will say you were saying that Tiago had a lot of questions. I imagine part of that comes from the fact that if you go there and figure out like one or two minor details, that like pays for the entire conference in itself.
Oh,
like
yeah.
like value wise.
Honestly, it was like consulting. Firstly, the talk was like meant to be 45 minutes or something, and Tiago had finished it in 20. So there was plenty of time.
I did have the opinion that originally I thought 45 minutes is too long to talk about something. And after all the questions, I took those questions as feedback. I got all those signals of how can I improve my talk for a next run. And I'm going to improve this. I'm going to have better examples, explain more some of the details, because one of the feedbacks that I got, and it was a very good feedback, was that when I talk about orchestration or choreography, one of the things you always read and it's always said is that choreography is usually good for small systems, but when your system grows, choreography might not be the best approach. And this is usually because in choreography, your systems need to know about all of the events, and you don't keep track anywhere of all of the chain of events that happen. So if you have 10 systems involved in a choreography, it's very hard to keep track of all the events that are consuming them. So it's harder to deal with than having one central brain that can know about everything. And I didn't dig too much into that when I gave my talk, and someone said, "Yeah, you just said that choreography is better, but I'd like to know why in bigger detail." And so that's one of the feedbacks that I got. But a lot of the questions that were asked are things that I can include in my talk. So it was a really good opportunity for me to also grow and learn from how I can improve this and how I can give a better delivery next time.
Well, to be honest, though, I mean, of course, you want the talk to contain everything. You want that to be a perfect kind of unit of information. I understand that. But I must say, this has been a long time since we were together, co-located in one place. And that conversation, I thought, was one of the highlights of the conference. Like, this was proper audience engagement. Some of it was you were just doing free consultancy live on stage. But there were some great questions. People had specific problems that they wanted to talk about, and I think that's kind of great. And genuinely, I think that's quite nice. That's something that you can do at those conferences that you can't just do online or not as easily, or with the recorded.
The problem with the questions is with your talk, you have everything under control. With the questions, anything can happen.
Yeah.
And this will stick to my brain forever. And this is my kind of addendum to my talk. But I remember saying, because someone asked about, I can't remember, I think they asked, what do you do if your system is taking too long to make these changes, or how do you deal with that? And I mentioned, well, usually your request won't take longer than 1 or 5 minutes. And I left that. And I'm like, who waits 5 minutes or 1 minute for a data change request? And I'm like, these things are like measured in milliseconds, seconds at the most, not minutes. And I'm like, oh my God. But there are actually transactions or long running processes that might take minutes. So it isn't that far-fetched, but yeah.
Yeah, no, it's fine.
I can understand that, especially because like one of the big pieces of advice I've seen people give to new speakers is just don't take questions if you're not comfortable with them, because that can be something that scares people away.
Yeah.
Which I understand. Like, you don't want somebody to come in and be like, I'm going to try to make you look silly or something. And you worry that's going to happen.
That's one of the beautiful things of this community, is that people are not judgmental, and people are not there trying to throw you off or see where your knowledge gaps live. They're there really genuinely trying to learn something. And I have no problem on stage saying, I actually don't know the answer to that. I say it in different words. I say it depends, which is a lot better than saying I don't know. You say it depends and it's done. But yeah, I feel like with this community, it's actually not that bad to take questions, because there's kindness there, and I don't feel like anyone is there trying to be mean.
That I know what you mean. And to be honest, Tiago, you did a great job. Like that.
Thanks,
as a session was like, honestly, if you did like a weekly just systems design hangout thing, I think that would be very popular. People would enjoy.
Or we can just invite him back into the show. Yeah, just saying.
Next time we've got a technical problem, we'll get Tiago back on.
Except our backend is not written in Go.
Is it not?
No.
Yeah,
that's
it's not going to be.
Daytime is written there. Changelog is written in, what was it? It's not
Elixir?
Rust, it's Elixir.
Elixir.
Oh wow, I have a big Elixir friend.
Oh,
he loves the language. Well, he's about my size.
Okay.
Are you
big?
I was thinking he's shaped like an elixir.
Big elixir.
What is it? What container is he in? Like, is that
imaginary friend?
Yeah.
Just my imaginary friend.
He is to Elixir the same way I am to Go. Like, he absolutely loves the language, but it's a very niche language, I feel.
Yeah, if you came from, if you were in the Ruby world at a certain point, at a certain time in the past, and I believe his name was Jose Valim or something.
He actually, so my friend works for the company that he started now.
Oh yeah, okay, there you go. So
I think
yeah,
so.
So he came from that, very active in that Ruby community, and then basically when he started working on Elixir, a lot of Rubyists were interested because of him as a stand-up person. So yeah, I think there's a I've I learned in the very early days, pre 1.0, I started learning Elixir. Right around those time, Go was also kind of becoming more and more popular. And I started looking at Go. I'm like, okay, so Elixir almost became my next language. And I discovered Go.
I see Rust. I see Rust as my potential secondary language. I feel like Rust is. It feels. I never actually did anything with Rust, but looking at just the docs and the way things are, it feels it's closer to Go than a lot of the other things that are out there. Like, it's not a Java-y type of thing. So it feels like a good next step.
Well, you'll have to let us know how you get on. Come back and tell us.
Yeah,
in a few years, maybe.
Yeah, like versus, like I keep seeing comparisons of people saying, yeah, Rust is better than Go, Go's better than Rust. I'm like, if I knew both languages, I don't think I would use them interchangeably at all. I think they solve very different problems in my mind.
And I think Rust, it still feels like a bit of an overkill to use for just normal systems like web APIs and whatever. It feels like way more low level than Go. I don't know if they solved it yet. I remember that a few years ago. It was still very, you had to use Tokyo for the HTTP library to do things, I think. So it felt a lot more lower level than Go.
Johnny, I just did a search for Elixir Johnny, and Johnny Depp comes up instead.
Oh,
because I think he's done some
something in that
Yeah,
area.
there's some like
it's a-
witches
is
or
it a
something
perfume or
mixing up
something?
some brews.
Yeah, I don't want to. I wouldn't want to compete with Mr. Depp.
No,
It's a tough one.
Yeah, it's a tough
Yeah.
one. Yeah.
but
Yeah.
yeah. But Go Lang Johnny is all you, mate. Until Johnny Depp, of course, starts doing Go.
Right. Then
know.
then it's
Does he have Twitter? Can we tag him?
Don't know.
hey, Mr. Depp. Interested in doing some Go this afternoon?
Well, then you'd have GoDep back in to play.
Oh,
yeah.
nice. Nice. Go Depp, this time with an extra P.
Yeah. Oh, here we go. This marketing started already. I'll manage your dependencies, mate. Here we are. We've got it.
Nice. We've got it. Oh, man.
Yeah. Okay, brilliant. Well, honestly, this was cracking. And I told you there was some gold in them there hills after the show. But it's good, wasn't it?
Yeah,
Enjoyed it.
a lot of fun.
Mm-hmm.
Indeed.
I'm really hoping somebody designs like a Johnny Depp pirate gopher and says this should be like the mascot for Go dependencies.
Well, there you go. You got the
I think
idea.
Naeem
Run,
said
run
that.
with it.
I can't draw it. I mean,
I'm sure we can find somebody in the community that can help you out with that.
Yeah.
I'm sure there are others that could do it. I have no
But
doubt
how-
about that. But
how
they all
long
tend to be
live-
super busy?
How long live will GoDep be, though? Will it still be in place for long? I actually don't know. Because with modules, we kind of don't
It's
need.
unlikely to stick around. I don't know. I don't feel like it's going to be maintained at this point.
Shall we just start the next Go Time FM episode now about GoDep?
Yeah. We'll get two for one. I'll do the whole episode in Johnny
Matt's
Depp's
coming
voice.
back.
Yeah.
Right.
I'll get a wig.
Oh, get a wig.
I'd love to see that.
Walks the file tree rooted at root, mate. I can get Johnny Depp reading the Go docs.
Yes, indeed.
Yeah. Brilliant. Okay. Well, we should say goodbye because we've got our live listeners still hanging on. But
This is true.
pleasure.
All
I
right,
don't know how
bye,
to
live
stop it.
listeners.
Don't know how to stop
Bye.
it without hanging up. Oh, probably the stop button.
The stop button in the middle.
Yeah, that'll do it. Okay. Thanks for.